In today's video, we'll discuss about Unix file APIs. Under this, we are discussing the general file APIs, file and record locking, directory file APIs, device file APIs, FIFO file APIs, then symbolic link file APIs. First, we will discuss the general file APIs. First, what do you mean by API here? API is nothing but application programming interface, nothing but system calls. Again, the system calls are nothing but small routine functions which will perform the specific tasks. In an Unix, these APIs are mainly used for implementation of specific commands with respect to the file handling and process handling. Okay. The first one, as I listed some of the APIs here. Open API, as the name indicates, this API is used by the process to open a file for data access. Second, read API, the API used by process to read the data from the file. Write API, the API used by process to write the data to a file. Else API, used by process to allow the random access to a file. Close, this API is used by process to terminate the connection to a file. Stat and abstract, API used by the process to query the file attributes. Chmod, the API used by process to change the file access permission. Chown, the API used by process to change the user ID and group ID of a file. Utime, the API used by a process to change the last modification and access time. Link, this API used to create the hard link of a file. Unlink, to remove the hard link of a file. Umask, to set the default file permission. First one, Open API. It is used to open or create a file by establishing a connection between the calling process and a file, which means that this API can be used to open a particular file to read the contents by a process, and also this API can be used to create a new file if that file does not exist. We'll see that how we can use exactly. The return value of open system call is file descriptor, which will contain the inode information, nothing but all file attributes of that particular file. If it is unsuccessful, returns -1. So here you have one question: what do you mean by file descriptor? File descriptor is nothing but integer value which is used to identify a particular file. And with respect to this Open API, the prototype, one thing you keep in mind, every API is with respect to the default header files like system or types.h. One more header file, that is Unix standard H. Okay, so these are the two header files we are using for any API here. The prototype for Open API contains three arguments mainly. One is path name is of type character, access mode is of type integer, permission is of type mode_t. I'll come to the point one by one. The first one, path name. The path name of the file to be opened or created, nothing but it specifies where exactly the file is located. So we need to open that file. Then this file name, this path name might be attribute or relative path name. We already discussed what do you mean by absolute and what do you mean by relative path name. Absolute path name is nothing but it contains the root directory, whereas a relative path name is nothing but it contains the current directory and parent directory symbolic notations. Next, access mode. An integer value in the form of manifested constants which specifies how file to be accessed by calling process. The manifested constant can be classified as access mode flags and access modifier flags. The first we'll discuss what we mean by access mode flags. We are having the three flags. One is O read only, O write only, O read and write. Here O stands for open. Here with respect to open API we are having the access mode flags. The first one is opens the file for read only, second one is opens the file for write only, and third one opens the file for read and write. And these access modifier flags what I had taken already optional and can be specified by bitwise OR, logical OR symbol we need to use. So always we are using these access modifier flags along with access modifier flags, access mode flags with access modifier flags. Some of the access modifier flags as I listed here: O append, O create, O execute, O trunc, O no ctty, O non-block. Again O stand for it is with respect to open API. Here O append is nothing but append the data to the end of the file, which means that whatever the content you are adding to the file, it is only adding at the end of the file. Second one, O create, it is create the file if it does not exist. Already I highlighted the one point that the open API can be used for opening a file or it might be creating the file. If creating that file does not exist, at that time we are using this flag. O execute used with O create flag. What it means that if the file exists, the call fails. Means the particular file name what we mentioned in the path name. Also with respect to that, if I mention the O create flag along with O execl and execl, so what it does means if that file already exists, then OpenAPI will be failed for creating the files. Next, O trunc. If the file exists, discard the file and set the file size to 0. Means already by default the file size is, say for example 20 KB, 30 KB. If it's having certain file size, then to make the 0, it will automatically set the 0 if I use the O trunc flag. Then O no ctty, that means specifies not to use the named terminal device file as the calling process control terminal. Means while handling the device files, every device file is represented by one file. That file itself is we can call as a controlling terminal, but if I specify this flag, then the corresponding file will not be used for controlling terminal. Next, O non-block. So that means any subsequent read or write on a file should be non-blocking, means it is a continuous operations here. So we'll have one example with respect to this. As I written, the path name of the file is program1, which is located under XYZ. Again, it is located under user directory. Then, as I mentioned here, access mode flags O read write. We are performing both the read and write. Then O append means we are adding the data at the end of the files. Then the third argument is only applicable if you are creating the file. So 0 means we are currently not creating any file here. Okay, fine. Next point, O append, O trunc, O create, O execute all are applicable for regular files, whereas O non-block is for FIFO and O no CTTY is only for device files. Okay, so these flags is specific file types. Next, the third argument, that is a permission in OpenAPI, is required only if OCreate flag is set in the access mode argument. Means that's what, if we are creating the file, then third argument is applicable, otherwise third argument is not applicable. Its data type is int and its value is octal integer value, such as, say for example, as I taken 764. Which here 7 is for owner, 6 is for group and 4 is for others. Others means already we discussed about the access permissions, read, write, execute for user, read, write, execute for groups, read, write, execute for others. So the 7 means, as I highlighted here, 3 will 1, that means one specifies the read, next one specifies the write, and next one specifies the execute. Remember about the absolute permissions. 4 is read, 2 is write, 1 is execute. So 4 plus 2 plus 1, that is 7. Means all the permissions we are assigning for user category. Next 6, that's 4 plus 2, only read and write. So specifies the write and read and write permission for group. If I take only 4, that indicate read permission for others. So here with respect to that integer, we can also use some manifested values. Just we can find it as a written yes underscore IRWXU. That means for user category we are assigning read, write, execute permission. Next, for group we are assigning the read permission. Next, we are assigning a write permission for group. Next, we are assigning read permission for others. So this permission value can be modified by calling process by using umask value. Here umask value specifies some of the access rights to be taken off or masked off. Means so you might be having the one question. By default, whenever the file is created, it will be created with all the permission for all the categories. That means read, write, execute. But that is not the final value. So it will be subtracted by 0 to 2. That means only user category is having the read, write, execute permission, and remaining will have only read and write permission. So how can we retrieve the current umask value? We can use umask API. Just we can go through here. So this one. Here this umask is nothing. It takes the new mask value as an argument, which is used by calling process and the function that is the old umask value. Just we can have one example here what we are doing exactly. So these are the values what I taken. Means currently we are execute permission from groups, write permission from others, and execute permission for others will be taken off. And this can be later on how we can used. See that actual permission is equal to permission and the negation of umask value here. This value is the final access permission. So this is the when we created the file, and this is the umask value. We are performing the logical AND operation. Then the resultant value what I am got is that will become the final one here.